Hello and welcome to the first chapter of the Murach's MySQL book. We'll be looking at the third edition of this book. It was refreshed in 2019. And in the first chapter, which is called An Introduction to Relational Databases, you'll kind of be learning about things that you need to know before you start working with a MySQL database or any other kind of a relational database. Okay, so the things that we're going to be seeing here are going to be general things that apply to all relational database systems, which is great because there are quite a few out there. And then in the second part of this first chapter, we're going to look at some of the specific like coding examples or SQL statements that we'll be learning later on in this book. We are not going to be looking at the details of those statements, but we kind of get a general idea of how it all works together. And also in the very end, we are going to be talking about how SQL works with PHP and Java, so that you have an idea of how applications actually use SQL to interact with databases such as MySQL. All right, let's get started. Let's go over some of the objectives of this chapter. They identify the three main hardware components of a client-server system. So the three main components are clients, servers, and then there's also the network. So that's the third component. Next, we'll describe the way a client accesses the database on a server using these terms. Application software, data access, API, data management, database management system, SQL query, and SQL results. So all these different terms we're going to have a discussion about in this chapter. In this chapter, you'll be learning about a lot of terms, right? So those are some. Describe the way a relational database is organized using these terms. So tables, columns, rows, cells, primary key, unique keys, and foreign keys. We'll discuss these concepts as well. Again, these are introduction. It's just going to be an introduction. We're not going to be diving super deep into them. The future chapters will do that job. Identify the three types of relationship that can exist between two tables. So three types of relationships are going to be one-to-one, one-to-many, and many-to-many relationships. And we will see some examples later on. Describe the way columns in a table are defined using these terms. So data types, null values, and default values. What are those things? We discuss those in this chapter as well. We will have a brief discussion about our entity relationship diagram and also the EER or enhanced entity relationship diagram to show how the tables in a database are defined and related. So the EER diagram allows you to have a sort of a visual representation of the entire database schema, and we will take a brief look at that. Describe the difference between DML statements and DDL statements. DML stands for data manipulation language statements, and DDL statements are data definition language statements. So manipulation would be something like insertion or retrieval, things like that. A DDL definition would be like creating a new table or a new database, etc. Would be considered a definition. So we will take some look at a few examples of those kind of statements. List three coding techniques that can make your SQL code easier to read and maintain. So we are going to also discuss how can you improve your code readability when it comes to writing SQL code. Super important. And then describe the use of a database driver. So in the end of the chapter we'll look at how you use other programming languages such as PHP or Java to interact with a database such as MySQL, and to do this you will need a database driver that allows the interaction to take place. So that's the last step. Again, you don't need to have Java background or PHP background to do any of this. We are just going to look at a very high level sort of thing. Cool. In case that you're not familiar with the client-server systems, first we're going to look at how a client-server system works, okay? And within that, we're going to first look at the hardware aspect of it, and then we'll talk about the software. Okay, so in a client-server sort of a system architecture, you will have mainly three kind of components, three hardware components, okay? The first one is going to be the server, the database server, and the second component are the clients. Okay, so you have three clients here. 1, 2, and 3, and the third component is going to be the network itself. Okay, so those are the three main components of a client-server system. The clients are the PCs, Macs, or workstations of the system. They can also be mobile devices like laptops or tablets and smartphones. So any lightweight computer can easily be performed as a client. The second one, the server, is a computer that stores the files and the database of the system and provides services to the clients. So when it stores databases, it's often referred to as a database server. Okay, so the servers tend to be a little more powerful. Okay, the power or the capacity or the capabilities of the server vary greatly, but they tend to be more powerful than the clients, for example. And the third part or the third component is the network. The network consists of the cabling, the communication lines, and other components that connect the clients and the servers of the system. Okay, so the network is oftentimes is the internet, but it's not necessarily has to be the internet. It could be a local network as well. All right, so talk about a little bit about the implementation details. So in a simple client-server system like the one shown here, the server is typically a high-powered PC that communicates with the clients over a local area network. Okay, so imagine that you have 20 computers connected in a lab, and there is one server. Maybe the instructor's computer is the server, and all the students have computers as well, and they are the clients. So the database is actually stored in the instructor's machine, and maybe the instructor has a more powerful computer, and the clients and the students are actually querying the instructor's computer to get data from them. Okay, and this is all connected through LAN, a local area network. So this would be a simple example of a client-server system design. The server can also be a mid-range system like an IBM Power system or a Unix system, or it can be a mainframe system. So as I said before, the server's capacity varies quite a bit. Like technically you could just run a server on a cheap Raspberry Pi, but it may lack the ability to process a high number of client requests, right? So oftentimes the servers tend to be quite powerful, and we're going to be using MySQL for this course. And MySQL is a cross-platform software, so it works on Linux, Unix, Macs, and Windows as well. So it works on all kinds of different servers, operating systems. A client-server system can also consist of one or more PC-based systems, one or more mid-range systems, and a mainframe system in dispersed geographical locations. Okay, so this, even though I just gave an example of a lab, but it could easily be spread across the entire globe, and that would then be referred to as an enterprise system. Okay. Individual systems and LANs can be connected and share data over large private networks, such as wide area networks or a public network like the internet. Okay, so sometimes these maybe we have one lab where we have all this going on with the 20 clients and an instructor machine as the server, but then there is maybe a few other labs similar to this one lab in the whole campus, right? And so in a situation like that, there is probably only one database server, the instruction machine, but there's a whole bunch of other local area networks which are connected and sending the queries to that one instructor's computer, okay, which is acting as the database server. So this can all, you can imagine like several different LANs connected together as only one database server serving them all. Okay, so that would be in a wide area network, sort of an example. Okay, so the point here to remember is that there are these three main components: the server, the clients, and the network. Okay, the scale is going to vary. The number of clients is going to vary. The strength of the server is going to vary. Even sometimes there are multiple servers. Okay, we will maybe see that later on, but it is possible to have multiple servers as well. And then sometimes, and the network is going to vary by how big the network is. It could be the internet, the biggest network of all, or it could be just a small LAN, which is only a local area network. Usually often in a single room or something like that. All right, so moving on to the next slide. So yeah, I actually just discussed those things. They are the three components, and the terms to know about client-server systems are local area network, wide area network, and enterprise systems. So these are arranged or sorted as based on the scale of the network. Next, let's talk a little bit about this the server software. Okay, now I need to just briefly mention this. When we say server, the word server can be quite ambiguous, and this is true for a whole bunch of different scenarios, not just databases. Sometimes when people say server, they mean the actual hardware, the computer, the machines, like the hard drive, the processor, and all that stuff. Other times they mean the server software. Sometimes they mean both, the total package, the hardware and the software. Sometimes it means one of the softwares that's running on the server. So it can be a little confusing what server actually means. Okay, so it all lies in the context. To understand the context is super important when we're talking about servers. Okay, so let's just keep that in mind, and I think as you guys gain experience, your concept of a server is going to get better and better. But for now, when we say a database server, we are actually talking about something that, for example, here this is the database server. It means that it is the database management system, the DBMS system, that's software installed on a computer. So you can think of it as, if I say database server, it means that the database management system, and it also means the hardware that's also in there as well. Okay, so just keep that in mind. Client softwares, let's talk about client software, server software, and the SQL interface. So here you can see that on the left side you have the client, which contains the application software, data access, API, etc. On the right side there is the database server, which contains the database management systems, database, DBMS basically. Okay, and here we have two arrows. Okay, so the SQL queries is the arrow that's on top, and there's the results arrow on the bottom, right? So whenever there is a communication going on between a client and a server, always the communication is initiated by the client. The client is the one who is going to be sending the first connection request, and asking the question, like SQL queries, right? And the database server is always listening. It always has his ear out for any questions that a client might ask. Okay, so if ever the client sends a question, the database server is listening on a certain given port, and as soon as it receives that request, it is going to, if everything is working normally, it is going to process that request in its server system and then return the results. Okay, pretty straightforward. Now let's talk a little bit of the details here. So let's talk about server software first. To store and manage the database of the client server system, each server requires a database management system like MySQL. There are a few others like Oracle has one, PostgreSQL is one, and there is several other. MariaDB is one. There's more. There are several others. But MySQL has been for a long time one of the top ones and very popular ones, and it is maintained by Oracle as well, and it is open source, so it's free and all that, and it's really high performance. So that's the server software. The processing that's done by the DBMS is typically referred to as a back-end processing. Okay, so this kind of processing is called back-end processing, and the database server is referred to as the back-end. Okay, so the database tends to be at the very end of the query, like the data, once you get the data back, at that point it's just sending the response back to the client. So it is usually it's almost always going to be referred to as the back end of a system. Then we have the client software. The client software, again, the clients can be your cell phones, your desktops and all that, right? So the application software does the work that the user wants to do. So for example, let's say you have an Amazon app on your phone, and that is your application software. Now the Amazon app, when you open it up, search for something, it's going to make a query to the servers. So all that is going on on the client side, like the user interaction, the typing of what they're searching for and all that, and then the client would actually generate that that SQL query and pass it to the server. So there is a lot goes on here. The data access API, or application programming interface, provides the interface between the application program and the DBMS. Okay, for example, if you're doing a Java application, for example, the most common data access API for MySQL is JDBC, or it's called which stands for Java Database Connectivity. Python has one as well. Something I can't remember the name, but there's one for Python as well. The processing that's done by the client software is typically referred to as front-end processing, and the client is typically referred to as a front-end. So the client is front-end, the database server is back-end. The request starts at the client end, and the response is generated by the server and returned as a set of results. Okay, so that's good to know. And the SQL interface, the application software communicates with the DBMS by sending SQL queries through the data access API. Okay, when the DBMS receives a query, it provides a service like returning the request data to the client. All right, so SQL is going to be used for this kind of query. So here, let's see, SQL queries. This is the interface this is the language that both the client and the database are going to speak and to communicate. Okay, so, and in this course we are going to learn to speak this language as well, so that we can talk to both the clients and the server. Now, so next, client server versus file handling systems. So before the database systems became popular, there was file handling systems. Okay, there are merits and demerits to both actually. So file handling systems still actually exist, and there are some advantages to file handling system because it allows you to kind of be the advantage of file handling systems. One of the advantages is that it allows you to have very heterogeneous database or heterogeneous data. When you have a strict MySQL like database, you have to keep things very well organized, whereas if the data that you're getting is actually really hard to organize and all, maybe a file handling system might be a better choice, but that kind of has certain big disadvantages in terms of speed and reliability and like authentic, the data correctness and all that stuff is not as good as a DBMS system. So in a client server system, the processing done by application is typically divided between client and server. In a file handling system, though, all the processing is done on the clients. Although the clients may access data that's stored in files on the server, none of the processing is done by the server. As a result, a file handling system isn't a client-server system. Okay, so say you have some sort of file sharing system, that's not the same as a client-server system. Okay, cool. So next slide. All right, so we did discuss these things just then. Next, let's talk a little bit about network layout, which includes an application server as well. Okay, so we have our familiar client on the left side. We have our database server and the DBMS and all that on the right side, but in the middle we have an application server as well. Okay, so the client will send user request to the application server. Then the application server which contains the business logic, for example, will then construct the SQL query based upon the user's request and forward that to the database server. Okay, and then the database server will formulate the results of that query and then pass it back to the application server, and then the application server might generate some sort of a response based on those results, and that is what is returned to the client. So the application server is going to play an important role in the middle here for checking the user request, and if necessary asking the database about the questions that the user is asking, and then returning the result. Some user requests may not even require an SQL query, could be something to do with a different part of the application. So in that case, it will not query the database. Sometimes the results that the database server is returning may not be something that should be passed to the client, so it can have some checks there, like let's say the amount of the stock, the inventory. Maybe we don't want to tell the client how many exact units of a certain product are available. That could be part of the business logic. So that kind of thing can be done using the application server, and it plays like a role of a gatekeeper, almost, which understands both the client and the database server. Okay, so and then another kind of server that you often see is the web server. So let's take a look at the next slide. And in this slide, it shows a simple web-based system. So here you can see on the left side is the client. On the right side we have the web server and the database server as well. Okay, and in the middle we have here we have the internet. Okay, so in the previous example that could have been a smaller network, but here we are showing usually when you're doing a web-based server, it's not necessarily always, but oftentimes it is working on the internet. So you have a web server and the client, and then it's internet in the middle. Okay, so in addition to sum it up, basically, in addition to database servers and clients, a client-server system can include additional servers such as application servers and web servers. Okay, application servers are typically used to store business components that do part of the processing of the application. In particular, these components are used to process database requests from the user interface running on the client. Okay, so that's the job of an application server. Now, but for the web servers though, web servers are typically used to store web applications and web services. Okay, so web applications are applications that are designed to run on a web server. Okay, these are a little bit different type of an application, which are designed to are optimized for running on the internet. For example, internet is not going to be as reliable as a standalone system. Okay, so when you are working with the internet, you need to be quite flexible in terms of, like, there could be sometimes interruptions in the connection, so you should be wait for that, and then you got to also make sure that the data that was sent over the network was actually correct data, or there hasn't been any dropped packages or anything like that, dropped packets. So when you're working on a web server, there are few additional constraints and questions that need to be asked while writing applications for the web. Okay, some of the popular programming languages used for develop such applications is one of them is PHP. Java is also very popular, and lately Python has been gaining a lot of popularity as well. Actually, JavaScript Node is probably gaining highest amount of popularity in recent years in this area, and it is a very hot skill. So that's the web server side. And more complex system architectures can include 2 or more application servers, web servers, and database servers. So like things can get super complex here as well, by having a bunch of application servers, a bunch of web servers, database servers. Sometimes, you know, they if you imagine like a huge some sort of a company which have database servers present all over the globe, okay, and they have like maybe 20 or hundreds of database servers, and they store, sometimes they store only part of the database, okay, which are necessary for that area. For example, let's say I'm going back to Amazon. I hope Jeff Bezos don't sue me. He loves to sue. Oh, I shouldn't encourage this, but let's say you have Amazon's spread across the whole world, right? So Amazon Canada has certain products that are more useful or more popular within this in this geographic location, right? So a database server located inside Canada maybe may have all this data stored in the Canadian data stored, right? And then there is another database, so let's say Amazon in Mexico, and the Mexican Amazon server may have data that is important for Mexico, but if someone from Canada wants to buy from Amazon Mexico, they could actually then their query will be passed on to that database server. So like the database servers have their own like connected, they're all connected, but the data that is being stored and the whole global database is actually like broken into smaller pieces and stored in these different databases. Sometimes there will be replication of the data as well. Like some of the data might be stored in both the databases, and that's okay as long as they are consistent. Okay, so these database server systems can get more architecturally complex. So all that is also true about the web servers, depending upon how popular the web application is, may have to create multiple servers. How redundant you want your web server to be, based on that you may want to have web servers, identical duplicate web servers present in variety of locations across the globe. You know, depends on the scale of the application. So yeah, as far as our course is concerned, this stuff is not going to be extremely important, but it's good to know just so that, you know, you're gonna have an idea of how these servers systems work. Okay, let's talk briefly about the relational database model. Okay, in 1970, Dr. E.F. Codd developed a model for a new type of database called a relational database. This type of database eliminated some of the problems that were associated with standard files and other database designs. By using the relational data model, you can reduce data redundancy, which saves disk storage and leads to efficient data retrieval. You can also view and manipulate data in a way that is both intuitive and efficient. Okay. In today's world, relational databases are the de facto standard for database applications. Okay, so this has just like been extremely popular, powerful, and just has taken over. Okay, now there is a lot of important concepts that, for example, what is a table, and columns, rows, primary keys, non-primary keys, indexes, all that stuff. So I wanted to kind of go over some of those points next. Okay, so here you can see the vendors table in an account payable database. So inside our account payable database, there is a table called vendors, and in the vendors table we have a bunch of columns, a bunch of rows, some primary keys. Okay, so we're going to let's have a discussion about all these different concepts. So first of all, it's important to remember that a relational database, okay, consists of tables. Tables consist of rows and columns, which can also be referred to as records and fields. Okay, so those are some of the terms that you need to be familiar with. Tables, rows, columns, and then rows can also be called records, and columns can also be called fields. A table is typically modeled after real-world entities such as an invoice or a vendor, but not always. Sometimes like student table could probably store information about a student, courses table for a course, so on. A column represents some attribute of the entity, such as the amount of an invoice or a vendor's address. So in this example, you can see this is a vendor's table. So we are storing the vendor's name, the vendor's address, etc. As these are the attributes, and those are stored as columns of a table, right? A row contains a set of values for a single instance of the entity, such as one invoice or one vendor. Okay, so if you have a student's table, for example, each row is going to represent a single student, right? So that's one instance. Here is an example where each row represents a single vendor. Now, the intersection of a row and a column is sometimes called a cell. A cell stores a single value. So when a row meets a column, you get a cell. So here, for example, this row number 5, for example, when it meets the vendor address 1, it gets 3000 Sindel Drive or something. Okay, so that's an example of a cell. Okay, now most tables have a primary key that uniquely identifies each row in the table. The primary key is usually a single column, but it can also consist of 2 or more columns. If a primary key uses 2 or more columns, it is called a composite primary key. Okay, a primary key is a very important concept which uniquely identifies a row in a table, and a primary key can consist of 2 or more columns. Okay, sometimes when you have more than one column, it's called a composite primary key. In addition to primary keys, some database management system lets you define one or more non-primary keys. In MySQL, these keys are called unique keys. Like a primary key, a non-primary key uniquely identifies each row in the table. Okay, you can have another sort of a unique key. Okay, a table can also be defined with one or more indexes. An index provides an efficient way to access data from a table based on the values in the specified columns. Okay, so in this case, the index would be the vendor ID. It is an efficient way to get to a particular vendor. If you know the ID, MySQL or most database management systems are very fast at retrieving that item if you know the value of the index. An index is automatically created for a table's primary and non-primary keys. Okay, cool. So next, let's go to the next slide. So I just covered all these topics one by one in the previous slide. So I'm going to skip over this one. Okay, so the relationship between two tables. Right, so let's talk about how two tables can be related. Okay. The tables in a database can be related to other tables by values in specific columns. Okay, in this figure, if you take a look here, we have on the top we have the vendor table, and in the bottom we have the invoice table. Okay, in the vendors table there is this column called vendor ID, and on the invoice table there is the second column called vendor ID as well. Okay, so in the top table, the vendors table, the vendor ID is the primary key, and it uniquely identifies each vendor. Okay, and the table below, vendor ID is actually not a primary key but a foreign key. Okay, and the foreign key this primary key and the foreign key together, they allow this relationship between these two tables to exist. Okay, so each row in the vendors table is related to one or more rows in the invoices table. This is called a one-to-many relationship. Okay, so take a look at this 123, vendor 123, Federal Express Corporation. So this vendor is present in a multiple rows in the invoices table. So we have many occurrences of the same vendor. So one vendor in the primary, the first table is present in on many rows on the second table, one to many. Okay. Typically, relationships exist between the primary key in one table and the foreign key in another table. So this is the typical sort of relationship you will find. The foreign key is simply one or more columns in a table that refer to a primary key in another table. Okay, so this, for example, is referring to the primary key in a different table, right? So that's what a foreign key is. In this figure, for example, the vendor ID column is the foreign key in the invoices table and is used to create the relationship between the vendors table and the invoices table. Okay. Now, a couple more points here. Although one-to-many relationships are the most common, two tables can also have a one-to-one or many-to-many relationship. Okay, so one-to-one or many-to-many. If a table has a one-to-one relationship with another table, the data in the two tables could be stored in a single table, right? If you think about it, if you have two tables and there's a one-to-one strict relationship, so technically all the data in the second table could actually just be stacked right next to the first table, right? Imagine if there's just like one row with 1, 2, 3, what you do is you take all this invoice number, invoice data, and all that stuff, and they just place it right next to it. Like, it is technically possible and won't be breaking any kind of rules. So that's what you can do with one-to-one. When you have in contrast, a many-to-many relationship is usually implemented by using an intermediate table that has a one-to-many relationship with the two tables in the many-to-many relationship. Okay, so imagine tables like students and courses. Okay, there's a students table and a courses table. So of course there's going to be many students in a single course, plus and also there's going to be a single student taking many courses. So that's a many-to-many relationship, right? So what you can do there is you can place a table in the middle. Let's just call it student dash course table, and this table is going to act like a bridge table where when then later on the relationship between the student and this bridge table is going to be one-to-many, and again between the bridge table and the courses table is going to be many-to-one. Okay, so you can take a many-to-many relationship and then place a bridge table in the middle, and then convert that many-to-many into one-to-many relationships, two one-to-many relationships. So that's part of good database design, right? So yeah, that's why we say that one-to-many relationships are the most common ones. Okay, so if you define a foreign key for a table in MySQL, you can have the foreign key enforce referential integrity. So when MySQL enforces referential integrity, it makes sure that any changes to the data in the database don't create invalid relationships between tables. For example, if you try to add a row to the invoices table with a vendor ID value that doesn't exist in the vendors table, MySQL won't add the row and will display an error. So what does that mean? Say you are trying to enter an invoice in this second table, right? and when you go to add the vendor ID, accidentally somebody enters the wrong vendor ID, and something like maybe they added an extra zero or something like that, and that so what will happen is MySQL will stop that, right? MySQL will check, oh, this vendor ID doesn't exist in the vendors table, so there's something wrong. So it will prohibit such an action, and that's how you can protect your data. So referential integrity is very useful for that. Okay. All right, so I think we have covered all the topics for this particular slide. And also the next slide here, all these topics are also covered in the previous slide: foreign key, referential integrity, and the 3 different types of relationships. All right, so let's talk about some of the things that a database designer will have to consider while creating a new table. Okay, when you are creating a new table, example here, we are creating the invoices table. We have to list all the columns that we are going to be, what the columns that we want in the table. Along with that, another critical property for a column is its data type. Okay, so for example, the invoice ID's data type is int. Okay, invoice numbers is varchar. Okay. With MySQL, you can choose from the data types listed in the next slide. We're going to see the next slide in a second. Or there is also more data types will be described in the future in chapter number 8. Okay, as you define each column in a table, you generally try to assign the data type that minimizes the use of disk storage, because that improves the performance of the queries later. So it's not just about less usage of the less storage. It's also about, if you are taking up less space, it's the returns are going to be smaller. So that will help you later on to make the application faster. So that's something we want to consider. We don't want to just have infinite lengths, for example. In addition to a data type, you must identify whether the column can store a null value. Okay, so here's another thing that you need to consider. So do you want the database to allow a storage of a null value against that particular column? So is it okay for vendor ID to be null? Well, if the answer is no, so you need to make sure that this not null property is applied or checked, for example here. So we are saying that vendor ID should not be null, invoice number should not be null, and all these things should not be null. But if you take a look at the payment date, that is okay if it is null. Maybe payment's not done yet, so it's okay for it to be null. And what does null represent? Well, null represents a value that's unknown, unavailable, or not applicable. Okay, so for example, payment date is a great example for that. If the payment hasn't been made yet, so that's probably going to be null. If you don't allow null values for a column, you must provide a value for that column when you store a new row in the table. So now that all these columns are actually not null, so whenever we enter a new row, we must provide these values. Okay, the only optional one is the payment date. You can also assign a default value to each column. So here, if you take a look at the very right, payment total and credit total, these two have default values of 0.00. Okay, so by default, those if you do not enter the value for these two columns, it will assume it's 0. Okay, then that value is assigned to the column if another value isn't provided. As you can see, 3 of the columns of the invoices table have a default value. All right, again, you'll learn more about how to work with null and default values later in this book. Each table can also contain a numeric column whose value is generated automatically by the DBMS. Okay, so if you take a look at this AI, it's not doesn't stand for artificial intelligence, it stands for auto increment. And this is checked for invoice ID. So invoice ID will be managed and incremented automatically by the database management system, DBMS. Okay. In MySQL, a column like this is called an auto increment column. You learn more about defining auto increment columns in chapter 11. Okay, again, this first chapter is just sort of an introduction and broad strokes for what's to come. So a lot of the things are just high level details and not getting really deep into anything. So just introduction to everything that's going to come. For now, just note that the primary key of both the vendors and invoices table, vendor ID and invoice ID, are auto increment columns. So here is vendor ID, sorry, the invoice ID here is, this guy is auto increment. Vendor ID here is not auto increment because this is the invoices table. In the vendors table, the vendor ID is auto increment. Okay, so let's take a look at the next slide where we'll learn about some of the common data types. So the first one is char and or varchar. There's, some people call this car, some people call it char. I'm not sure what is the correct pronunciation, but both of them are fine. I know both two people who go either way. So char or varchar are going to be used to store character data, like strings, for example. In Python, you may have strings in other languages as well. So that's what char and varchars will store. Int is going to store integer values, so whole numbers, and then decimal is going to store floating point numbers, like big floating point numbers. Float can store smaller floating point numbers, and date can store dates. Okay. All right. So that's it for this slide. Terms to know about columns: data type, null value, default value, and auto increment column. So again, as we discussed, each column is going to have a certain data type. It may or may not have a null, not null property, and it may or may not have a default value. And sometimes, commonly for primary keys, we may enable the auto increment column. So that helps because then we don't have to manually manage the value of that particular column, and the database itself takes care of what the value should be. When working with relational databases, you can use an entity relationship diagram to show how the tables in a database are defined and related. Or you can use a newer version of an ER diagram, also known as EER diagram or enhanced entity relationship diagram. Okay, here's an example of an entity relationship diagram. So what is going on in this diagram? So you can see that there are 5 these rectangular shapes, and there are a bunch of lines that are connecting them to each other. Now, if you look at the top blue line here, you can say it says vendors. Similarly, there are terms, invoices, invoice line items, and general ledger accounts. Okay, so those 5 are the tables in the database, or the schema in our case. Okay, and inside the each of these boxes, there's a whole bunch of lines written here. And so the first one here is the vendor ID, and it says int, and it has you probably can't see, but it has a small yellow key icon next to it. Okay, what that means is that it's a primary key, and the name of the field is vendor ID, and the data type's int. Okay, we won't go into a lot of details here, but some of these lines that you see and the endings of the lines also have special meanings. Okay, and so that's the ER diagram, or enhanced entity relationship diagram. For now, just know that an entity relationship diagram, or an ER diagram as well, can be used to show how the tables in a database are defined and related. So although SQL is a standard language, each vendor has its own SQL dialect or variant that may include extensions to the standard. Okay, a variety of companies have come up with their own SQL-based database management system. Like Oracle has its Oracle database, MySQL, as well as Microsoft has its database system as well, Microsoft SQL Server. There are quite a few others, okay, like that. So each one has a few specific details that only apply to that one, but the basic SQL remains the same across all the different SQL-based database management systems. Okay, so this is why we call this standard SQL. The standard SQL is the basic SQL statements that are the same for all dialects. Once you know one dialect, you can easily learn others. Okay, so let's say you are pretty well used to working with MySQL, but then when you go to you're working for a company, you find that they're using Microsoft SQL Server. So since you already know MySQL, it should be pretty easy for you to actually learn the newer details, the minute nuances of SQL Server, and then start writing code in that. Okay, how knowing standard SQL does not help you is that most applications that are non-trivial, that are big applications, are going to require modifications when moved from one SQL database to another. So if you have something already set up in SQL Server and you want to move it to MySQL, it's going to require some significant changes. Okay, so that's when it doesn't help you. But when you want to learn about these concepts and the syntax, you just have to pick one of the platforms and then just learn it fully, because then later on, if you are you get thrown a new one, it should be pretty simple for you to like migrate. Right, so a little bit of the history of MySQL or SQL in general. In 1970, Dr. E.F. Codd developed the first the relational database model, as we said before. In 1979, Relational Software Inc., later renamed Oracle, released their first relational DBMS system. Okay, so Oracle was initially called Relational Software, and they released their first version of the proposal that Dr. E.F. Codd had made about relational database model. And DB2 was released by IBM in 1985, but the first version of the software was released in 1982. But then DB2 was released in 1985, which became quite popular. And Microsoft back then was a huge company as well, and they released their own version a couple of years later with SQL Server, 1987. And after that, MySQL actually became an open source project in the year 2000. In 2008, Sun Microsystems acquired MySQL. Sun Microsystems was this huge company which also owned and managed the Java project, the Java programming language. They also had a business of building huge servers and all that kind of stuff. They were a big company, and in 2008 they made this acquisition of MySQL. A couple of years later, Oracle acquired Sun Microsystems. So Oracle in 2010 decided that they're going to buy the whole Sun systems, so all the servers, all the operating systems that Sun used to maintain, all the languages that Sun used to maintain, open source projects, everything was now managed by Oracle. So when this acquisition took place, some of the developers who used to work on the MySQL project did not really like this very much, So soon after this acquisition, many of the original developers of MySQL left and began working on a fork of the open source code and named MariaDB. So they took MySQL and then they started working on that, making it better, and they named it MariaDB, which still exists right now today. It's one of the another popular database systems. Okay. In 2016, ANSI published SQL 2016, which includes support for regular expressions and JavaScript object notation, so JSONs. So ANSI is trying to update SQL to meet today's demands of JSON and regular expressions. Now, operating systems wise, Oracle, DB2, these two mainly go Unix, are used in Unix. SQL Server is mainly Windows. MySQL is a very cross-platform database system, and it works on Unix, Linux, Windows, Mac, you name it. So that's the one that we'll be using in this course.